Hey there, awesome physics students. Let's talk about where this buoyant force comes from. We know that buoyant force is the weight of the displaced water, but there was no explanation about what the origin of this force is. Well, let's imagine a tank of water here. And just for right now, just forget about the buoyant force. Just know about pressure. Pressure increases with depth. And the amount that pressure increases with depth is just the density of the liquid or the fluid in here times the gravitational constant times h. H is the amount that you go deeper than you were before. Okay? If you hold a brick or something in here, and again, forget about the buoyant force for just a second, there's going to be pressure exerted on this at all sides. Now, this side-to-side pressure is not going to push it up or down. It's going to be totally symmetric and won't have an effect, right? But the pressure at the top will push down and the pressure at the bottom will push up. And which of these is bigger? Well, we know that pressure increases with depth. So the pressure at the top is going to be smaller than the pressure at the bottom because the bottom is deeper. And how much is it deeper? It's deeper by an amount h. And so the increase in pressure is going to be, imagine this, if this brick had a height of h. Then the amount that the pressure is larger is just rho gh. Now what happens if you take this brick and you put it even lower or deeper in the water? Well, the pressure on the top is going to be increased, right? Because now you're deeper in the fluid than you were before. But again, the pressure on the bottom is going to be even bigger than the pressure on the top because the bottom is still deeper, and it's still deeper by the amount h, or in terms of pressure, that would be rho gh if the height of this brick is h again. So no matter what you do, the force on the bottom is going to be a little bit bigger because the pressure is going to be bigger on the bottom. And the key here is that the amount that the pressure is bigger on the bottom is the same no matter how deep you go. Yes, the pressure on the top gets bigger, but the pressure on the bottom gets bigger by that same amount, but the difference between the top and the bottom remains the constant. The difference only depends on the height of the brick itself and does not depend on how deep you take it in the fluid or how shallow it is. So overall, where does the buoyant force come from? Well, the buoyant force comes from this amount of pressure, being the bottom is a little deeper than the top. The buoyant force comes from pressure differences. In other words, the buoyant force comes from the fact that the pressure increases with depth, and that the pressure on the bottom is going to be always a little bit bigger by the same amount than the pressure on the top.